EV Brief is your home of topical Australian electric vehicle and sustainable transport content.
Today I'm joined by Mark Peters from Transit Systems. Mark, thank you very much for your time today and thanks for joining EV Brief podcast.
You're welcome.
Now your role, you're the General Manager of Fleet Innovation and Business Intelligence at Transit Systems. Can you explain to us a little bit about your role and what it involves?
Sure. So I've got three main portfolios that I look after. So as my role as General Manager Fleet, I look after around 3,000 buses across the country. So approximately 800 in Perth, 800 in Adelaide, 800 in Sydney, about 170 in Victoria, and also around 350 buses in the mining and resources area of Western Australia. In my fleet role at the moment, primarily my task is transitioning from internal combustion engines to zero-emission buses. And we have a number of zero-emission buses across the country at the moment. We have 55 battery electric buses in Sydney, we have 4 battery electric buses in Perth, and we have 1 old battery electric bus in Adelaide. And we're also working on a couple of projects at the moment with 9 battery electric buses in Victoria, 2 hydrogen fuel cell buses in Victoria, and a further 2 hydrogen fuel cell buses that we're working with our clients to deploy those buses. So that's the fleet role. The innovation part of it relates to our fleet and new technologies. For example, we're working on technology at the moment that detects fatigue and distraction, and also driver assistance programs that monitors pedestrian warnings, headway management warnings, lane deviation warnings. So that's one of the projects that we're working on with innovation. And the third part of my role is business intelligence. So we are a very data-rich organisation and a data-rich industry, and we're looking to bring those big data sets together and put them in visualisations that managers can use to make informed decisions about their business.
I suppose even more so in this day and age with EVs now, data is even more prevalent with the telemetry that you're getting in real time from these buses, isn't it?
Most definitely, and there's a lot of people looking for that intelligence. For example, what the average net energy consumption is for a bus, what our average state of charge is, what average distances do we operate, what are the minimum state of charges that we get down to, what is the average charge time. So there's a lot of requests for information. We've been operating these buses for over 3 years, but still early days.
So it's interesting that you mention the transition to electrification as actually the first thing, one of the key tenets or objectives of the business. That is something that Transit Systems is really pushing for now, is it?
Yes, it's a part of our strategic plan to be a leader in the zero-emission bus transition. So we've engaged reputable industry partners. We've been involved in this transition for some time, and we see it as important to us as a business to lead the transition and to assist governments to meet their zero-emission bus transition their goals. So we're working closely with governments, closely with partners, and closely within the different business units within our organisation to lead and accelerate the zero-emission bus transition.
It's interesting, isn't it? Because obviously from your business point of view, electrification makes a lot of sense in terms of operational costs and life cycle costs, but you need signals and policy from government, don't you, to really push forward? And we've seen that in New South Wales with a commitment to go zero emission completely by, I think, 2030 or 2035. Do you see the rest of Australia, in terms of metro and regionally, going all electric eventually?
Eventually, yeah. Each state government has different appetites and different accelerations for the transition. So in New South Wales, we basically haven't been able to procure an internal combustion engine bus for approximately 2 years now. Victoria have made a decision to only procure zero-emission buses from 2025, and other states are considering their policies at the moment as to when to draw a line in the sand to say no, we're only going to procure zero-emission buses from this date forward. And it is important because we rely on the government as our clients to provide that policy
course.
to determine on what buses we can buy. For example, in New South Wales, there's a procurement panel, and we can only buy from that procurement panel.
Yep.
So there's about currently 5 or 6 different zero-emission buses on that panel, and similarly in other states there are different frameworks. But yeah, we are reliant on our government clients to be able to give us an indication as to what their acceleration appetite is.
Yeah, because also at the end of the day, this is a business as well. You know, you're not doing this for fun. So there has to be benefits on all sides, doesn't there, with this transition?
And the benefits are diverse.
Of course.
It has been a good change to come at a good time. So there hasn't been a lot of change in the bus industry. There's been incremental change, but this has been a significant change. One that I think that both the asset management team and also the bus operations team have enjoyed. It's a new set of skills. They're learning new things. The drivers are learning how to drive these new buses. Teaching the drivers how to maximise the benefits of regeneration is an important part of the transition. Teaching the asset management staff about high voltage systems and the safety requirements around that is very important. So it's not only the environmental benefits, the emissions and the noise. Our customers enjoy the zero-emission buses. They're telling us through customer feedback that they enjoy the ride, that it's smoother, it's quieter, and it's far more comfortable than an internal combustion engine. So yeah, it goes far wider than just the environmental benefits.
Totally. I'm on the 442 every day or every other day, and just love it when the electric bus comes along, because you know it's going to be a great ride.
That's right.
And it's silent, and when they go past, they're so much better than those diesels.
They are, much better.
So it's really interesting what you were talking about just before. There's obviously it's a total rethink for the business, and there's a lot in terms of safety and in terms of training that needs to take place. And we'll also see, I think, a bit later, we'll actually look at the depot and see what infrastructure has needed to change. But have you had to retrain the drivers in their sort of operation of these vehicles? Is there a massive change from diesel buses?
It's not a massive change, no. Obviously the bus still has standard steering, brakes, suspension, but the way that they drive the bus is different. So as I mentioned before, the regeneration and maximising that, because when you introduce new drivers to the electric bus fleet, you do see a slight deterioration in the regeneration rate.
Yep.
So teaching the drivers how to maximise that regeneration is important, because it lowers your energy requirements that you need to charge back into the buses. And also it's important to teach the drivers about the safety systems that are required on the bus, the shutdown procedures,
of course.
How to use the main safety device shutdown systems. So that's important to let the drivers know about that.
Now you've got a broad range of experience, I believe, across management, but also the technical side, the servicing side of this business, haven't you? So what would you say is your kind of favourite aspect of this transition now?
My favourite part of the transition is learning the stuff that I haven't necessarily been exposed to in the past. I'm an auto electrician by trade, so I enjoy the technology of the bus. I enjoy learning the different systems on the buses, but what I'm finding interesting is learning the outside depot energy requirements and the processes and the frameworks and the procedures about working with energy regulators and energy networks to be able to bring enough energy to the depot boundaries to be able to charge the buses.
Yeah, well, that's a fantastic segue to my next point, because obviously each bus has, was it 360 kilowatt hours on average on top and underneath it?
Yeah, the Nexports have 368 kilowatts and the Yutongs have 422 kilowatts.
So that's a hell of a lot of power.
It is.
And times 55. Now, what does that mean in terms of charging for the depot, and how do you balance charging 50 to 60 buses on a daily basis here?
Yeah, so there's different stages of zero-emission buses. We started off with 4, and we only had what's known as dumb charging at the time, where you plug the system, plug all the buses in, and you get full power straight away. Now that we've got 50 buses, we've transitioned to smart charging. So we now have a software platform that manages our charging. So it can prioritise. And we've set up the system to have priority zones. So obviously the buses that are parked in front need to be charged first.
Mm-hmm.
So it prioritises that zone or that area to ensure that we can dispatch those buses, and then the buses behind it can then go out. So getting that energy requirement has been one of the challenges, and will be moving forward, because, as you said, the buses consume a lot of energy to recharge, and most of the depots, as they stand, the brownfield depots, they don't have enough energy requirement in in the existing depot infrastructure, and potentially even in the feeder lines in the street. So we may have to, at different points, run new feeder lines for a couple of kilometres back to the zone substation to be able to get enough energy to the depot boundary to be able to charge the fleet.
With the feeder lines, what conversations can you sort of reveal a little bit about the discussions that you've had with energy suppliers in terms of ensuring that the depot is able to support this fleet?
Yeah, so there's processes and applications that need to be made to determine what energy is available in your local feeder lines. And then you need to have an assessment on what your energy requirements are, and to be able to put that into the application to advise the network what energy requirements you need. And then they come back with a proposal as to what the requirements are, what the design is, and the costings around what that would look like.
Okay. So with an all-electric future, obviously Transit Systems will eventually be considering an all-electric depot in the future. So depot design and planning will probably need to change, won't it?
Yeah, definitely. Depot design is one of the critical factors of the zero-emission bus rollout. Being able to install charging infrastructure but minimise the impact on the parking footprint. We operate a lot of depots that are already congested, and by adding charging infrastructure, it just builds on that congestion and potentially limits the number of buses you can park on site.
Right.
So we're looking at infrastructure at the moment that minimises that footprint and maximises our depot parking capabilities.
Right. So which are your depots in Sydney, in Metro Sydney?
So we have 6 depots in metropolitan Sydney. We have 4 depots in what's known as Region 6. So we have Burwood, Kingsgrove, Leichhardt and Tempe. And in Region 3, we have Hoxton Park and Smithfield depots.
Okay, fantastic. So yeah, in terms of charging now, with the BYDs, they have an AC input, don't they?
They do.
So they convert that to DC for the motors, is that right?
Yeah, they convert from AC to DC on the bus.
Yeah,
so
right.
when you go and see the infrastructure out in the depot, you'll notice that the AC charges are much smaller than the DC charges.
So what sort of time are we looking at in terms of reaching maximum state of charge on these?
So our buses usually come back to the depot with between 40 to 50% state of charge. So we don't really get down to the critical levels, down around the 20%. So our average charge time is just under 3 hours.
Okay.
So from that 40 to 50% state of charge to 100% is roughly around just
really
under
not
3
long
hours.
at all.
Not long.
Considering. And
no.
Do you tend to charge to 100% for every route, before every route?
Yes, we do.
So it's that same pattern.
At the start of the morning, before 4 or 5 a.m, before the buses start to roll out, we like to see every bus at 100%.
Okay. Yeah. And do these batteries have a sort of charging curve that's software controlled, similar to passenger cars, or does it sort of charge in a linear fashion all the way to 100%?
The software has algorithms in it that obviously prioritises the zones that we've set up. So it is a smart charging system, and it will disperse energy across all of the charging systems based on the algorithms and the parameters that the operator has set up.
Okay, so it's basically probably like a lot of things in the bus, like the regen, I believe everything's fixed, but it is all configured before the buses go into operation by you guys to meet the needs, right?
Yeah, that's exactly right.
Yeah, fantastic. So in terms of, I suppose, more into the granular, the operational side of things, these buses, what sort of efficiency are you getting? Do you know those figures from the routes?
Yeah, so the net energy efficiency rating is somewhere between 1 and 1.1 kilowatt hours per kilometre.
Okay.
So that's the net result. So that's taking into consideration your total energy consumption.
Sure.
Taking away the regeneration, the
Sure.
free energy that's generated throughout driving, and giving you that net energy consumption rating. And when you normalise it per kilometre, it's between 1 to 1.1 kilowatt hours per kilometre.
Which is actually, for a pretty heavy vehicle, what are they, 18, 20 tonnes?
18 tonne gross vehicle mass. Their tear is around 14 tonnes.
Okay. So it's actually probably pretty similar efficiency to a heavy passenger EV.
Yeah.
Yeah?
Yes.
All things considered.
Yes.
Yeah, wow. Okay.
Yeah.
Interesting.
Yeah, we were surprised to see that. We were surprised to see the excessively, not excessively, but the high regeneration rate. We're achieving regeneration and energy of around 35%.
Wow.
Regeneration rate. So
that's where bad Sydney traffic really has some benefits.
that's exactly right. Yeah. Traffic lights, traffic in general,
Yep.
and slowing down for turns. That's where you get the benefits of regeneration.
So I suppose that's one consideration as you roll out these buses to regional areas. Will they be able to deal with the demands of greater distances between stops and less regeneration over, say, 200-300 kilometres?
That's exactly right. So your range is going to reduce, your regeneration is going to reduce.
Charging times will go up.
Charging times will go up. Your energy consumption per kilometre will go up.
Yeah.
So we're interested to see what the data looks like in different operating environments.
Now, in your control room, you can actually see all the data in real time, can't you?
That's correct.
See,
So you can see the current state of charge.
Amazing.
You can see an estimated range before the bus gets down to its critical levels. So we can see every bus on a screen live.
And is that just to ensure that everything's running as planned and is consistently? You're not sort of giving directions to drivers at all, are you, or telling them to drive in certain ways?
No, it's just an information screen.
And then obviously it's all collated and then and mapped.
That's correct.
Point.
Yes. So we're lucky. We haven't had a bus run out of charge. The buses have what's called a limp mode, where once you get to 20%, certain restrictions kick in on the bus.
Okay.
When you get down to lower levels, more restrictions come in. So the bus doesn't actually stop.
No.
It just becomes more and more difficult to drive. You lose a little bit more of your comfort features. But we don't get down to those levels.
No.
So if we had buses that ran closer to the line, that we'd be paying more attention to the live screen.
Sure.
But it's just an information tool that our operations staff use to ensure that the buses are meeting their requirements.
Yeah. Now, in terms of requirements and operation, is it too early to tell, or have you been able to see some real operational cost savings over the diesels?
It's not too early to tell to see some initial benefits, and the operating costs at the moment are substantially lower than a diesel bus. Depends on which diesel bus you're comparing it to.
Of course.
Are you comparing it to a diesel bus that's within a warranty period? Are you comparing it to a 10-year-old bus or a 20-year-old bus?
Yeah.
But at the moment, indicatively, the battery electric buses are approximately 70% cheaper to operate than an internal combustion engine.
That's huge.
It is. But then you have to offset that against the initial upfront capital cost of the bus. And then what is too early to tell is the longevity and the life of the electrical components of the bus. So it is going to be a bit of a process to determine whether our assumptions in total cost of ownership over a whole 20, 25-year life cycle, whether the electric bus is cheaper than an internal combustion engine. Our assumptions say that they are. But we just need to ride out that first life cycle to test the componentry, the motors, the converters, and just determine that their expected life is meeting their actual life.
Because presumably, like any other EV, battery degradation is going to be a factor over the operational lifetime of these vehicles. Because you tend, how old's the sort of fleet generally? What's the average age of the fleet?
So we've got buses that have now gone over 3 years,
Yeah, yeah.
and we've got a range of buses, about 15 of them that have only been in service for approximately 3 to 4 months.
Okay.
We haven't seen the buses that are 3 years old. We haven't seen any battery degradation at this stage.
Yeah, wow.
We know it is coming, and we will be tracking it. But at the moment, the batteries are performing very well, and that's another unknown. The battery warranty periods are for 8 years.
Okay.
So that's the warranty period. But what is the actual life of the battery? Is it 8 years plus a month?
Yeah.
Is it 10 years? Is it
Yeah.
12 years? We don't know. Under these conditions, under this operating environment, what is the life of a battery?
Yeah.
So,
Are they a similar chemistry to BYD's other batteries? Are they like a lithium-ion
yes, they are.
phosphate? Or?
Yes.
Okay.
Yeah.
Right,
Yeah.
right.
Both of them, both the Yutong and the BYDs are lithium-ion.
So they actually enjoy being charged fully and sort of deep cycled.
That's correct. Yeah. There are other battery types that don't necessarily like to be charged to 100%.
Yeah.
So there are batteries that are getting charged to 80% in different fleets.
Yeah.
But no, these ones here we charge to 100%.
Yeah, wonderful. Now, when I was last here, Greg Balkin was talking a little bit about, I suppose, hydrogen is being considered or being trialled in Europe, where you have depots and buses over there. Is that something that is on the cards for Australia possibly in the future?
It is. So Transit Systems have bought 2 hydrogen fuel cell buses. I actually drove one of them about a month ago. So they're here. They're in southwest Sydney. We're talking to a couple of government clients at the moment, and discussing potential deployment plans to get these hydrogen buses out there to test and demonstrate the technology. So hydrogen has been around for some time. We operated hydrogen in London from 2013 to 2020. So the technology is there. The technology is proven. We're looking to demonstrate that technology in Australia.
Yeah.
And we're hoping that we can get our government clients on board to launch a deployment project in the very near future. So they're the 2 photon buses that we have,
Okay.
and we can touch and we can feel. We're also working with the Victorian government on a 2-bus hydrogen fuel cell project, looking to deploy that in early 2023 as well.
I think hydrogen has a lot of benefits, particularly in commercial and bus applications, because you have the potential to generate your own electricity on site and electrolyse the hydrogen on site. Obviously, there's a big capital cost to that, but it could be something in the future that actually makes sense.
Definitely.
For business. Yeah.
So medium to large scale, you do look at on-site generation.
Yeah.
These small scale projects that we have, we're looking to demonstrate the technology of the bus. But yeah, the benefits of hydrogen go in a number of different areas. So range is one of the obvious benefits,
Yeah.
and probably the most publicised benefit of hydrogen over electric. But the benefit that I see in congested depot environments is that hydrogen has a far more traditional refuelling process, where the bus pulls up to a refuelling station, it's refuelled, and you can go and park it in an unobstructed depot yard that's not full of battery charges. So it'd be interesting to see how hydrogen plays out with battery electric and charging infrastructure over time. We definitely see that there's a place for both technologies.
Yep.
And we look forward to launching these hydrogen fuel cell buses in the very near future.
Yeah, fantastic. And finally, I just wanted to ask about the depot infrastructure as well, because I believe you've got some solar generation capabilities now since I was last here.
That's correct, yeah. We've got 862 solar panels on the roof of Leichhardt Depot where we are today. So that's generating 388 kilowatts during peak periods. And that solar then integrates with a 2.5 megawatt, 1.3 megawatt hour Tesla battery. And that system is then integrated to the grid. So you need a really big solar farm and extremely large battery storage system to be able to charge a whole fleet. So the solar and the battery won't be enough to charge the whole fleet. But what it's designed to do is, when our buses come back after the PM peak around that 6:30 PM period, we can plug the buses in and put them on charge straight away and discharge the battery into the buses, and we can charge them basically for free. And that period is still during the peak network period. So we're not paying those high tariffs during that period. As the battery discharges and runs out of charge, that will then be after 8 p.m. and you're then into off-peak period.
Yep, and then basically the battery is ready for the next day to be refilled by the solar.
That's exactly
Fantastic,
right.
just like home systems.
That's
Wonderful.
right. Yep.
Well, look, thanks so much for your time today. It was really wonderful to meet you, and I look forward to having a look at the depot.
It's great to meet you too. Thanks very
so
much.
Mark. Thanks.
Thank you.
Okay, so Mark, what are we looking at here?
So this white container-looking piece of infrastructure is actually the Tesla Megapack 2 energy storage system. So as I said before, 2.5 megawatts, 1.3 megawatt hours. Then
we've got our distribution boards here.
Yeah, just to the right here is a new main switchboard. This main switchboard here is the interface between the solar, the battery and the grid. And then just on the other side of this switchboard is another new main switchboard. And that switchboard there talks primarily to the distribution boards in the yard. That's a new transformer.
Yep. And then how far is the nearest substation? Where does that come from?
We were lucky enough to connect here.
Right.
So there are 11,000 volt lines in the streets.
Yep.
If you have enough energy available in them, you can tap into those. If not, you then have to put new feeder lines back to a substation. So there's two main areas here.
Okay.
This is our dispatch area.
Amazing.
And we originally had one screen with a fixed, because we only had 5 buses for a period of time. Now that we've got 55 buses, they scroll across, and we are reviewing that, and we're trying to work out the best way to visualise the state of charge of every bus. But as you can see there, you can see the bus ID. You can see visually what the state of charge is like per bus. You can see whether the bus is in the depot, on the road. Whether it's a VOR, which is vehicle off-road. You can see state of charge, estimated range remaining for that bus, and you can see the current efficiency rate. So,
amazing. It's everything you'd really need. Do you sort of get any audible or visual warnings if anything is outside the operational parameters?
Not at this stage. Not at this stage.
You probably don't need to, because everything just works pretty smoothly.
It just works. Yeah, you can shut your eyes and it just works. So it's good.
So this is the control centre?
So this is our operational control centre, yep. So the team in here manage our headway services and all of our other services. So this is our two-way radio communications. We use a system called P-TIPS where we can see every bus live. We've got direct links and direct communications to the Transport Management Centre and emergency services.
So if anything happens, basically these guys are the first point of call for
This is where
drivers,
it all happens. Yep. So if anything happens on the road, the instructions and the training to the drivers is to call the OCC. 120 kilowatt Feehong DC chargers, and over there's the 31 BYD 80 kilowatt AC chargers.
So sorry, you've got the Yutongs charging DC, is that right?
That's correct.
And the BYDs are all AC.
Yes.
Yeah.
So on this part of the yard, we've got 9 DC Yutong buses being charged by 5 dual port 120 kilowatt Feehong chargers, and we've got 31 next port AC buses being charged by 31 BYD AC chargers.
So these ones you can charge 2 buses simultaneously.
That's correct.
120 kilowatts.
Yes.
So what's the sort of charge time from 30-40%?
So interestingly, they're still around because it all depends on state of charge, right? So our average charge time since introducing the DC chargers hasn't really changed too much. So whilst it's dual port, it's only 120 kilowatt maximum.
Sure,
So if you plug in 2 buses, you're charging each bus at 60 kilowatts.
Okay. But still, you're not really looking at a huge amount of downtime. I mean, I suppose most people are thinking, oh, you got to have electric buses. You got 5, 6, 7 hours out of service. It's not the case, is it?
No, it's definitely not. So yeah, just under 3 hours.
Yeah.
And our operation actually lends itself to that. Most buses are back in the yard, tucked in bed by 11 p.m. and our first buses don't go out till just around 4 a.m. We do have a couple of buses that are out for all night services, but
you got clear 4 or 5 hours there.
Our operating profile definitely meets the the profile of electric bus charging.
Yeah. That's definitely not electric, that one.
That is definitely not electric.
So this is exactly as you'd see at a rapid charging station on the highway for a car. You've got your DC CCS connection there with your 2 pins at the bottom, right?
Correct, standard
Yep,
plug.
standard plug.
Yep. So that can charge any CCS2 compliant vehicle. Yeah, you're right. Just infrastructure that you would see at any charging station.
Yeah. So we've got the AC chargers over here. I think you had one of these under an undercover area when I was last here. You had maybe a couple of these near the service area.
So originally we had
That's
4
right
down
over
in
there.
the charging bay.
Yeah.
We've now got 6 down there.
So these are manufactured by
BYD.
themselves. Okay.
Yes.
Yeah, you can see the label there. So these are 3-phase
80 kilowatt.
80 kilowatt.
80 kilowatt
Three-phase
AC.
80 kilowatt AC. Wow.
Yes.
Okay, fantastic. And again, similarly, is that output shared?
That's correct.
Across
Yes.
2 chargers? Okay.
Yeah. So we use these as a 1-for-1. So we put both guns into one bus. So one gun charges the upstairs batteries, and the other gun charges the downstairs
okay,
batteries.
so literally a double barrel kind of.
Correct. Yes.
Amazing. Because I'm a bus nerd, I always like getting on buses anyway.
Yeah. Hop in, have a look.
Thanks. So it's all pretty straightforward. You've actually got an RPM indicator there, which is interesting. You've got your speed, you've got your fire suppression system over there, and then all your bus controls, radio, that sort of thing. So,
Yep, that's correct.
and then presumably you can just see the state of the batteries and the air compressor and things on there. So
That's right. Yes,
Yeah.
that centre display has all of your features. You've got your air gauges up the top.
Yep. And in terms of the driving, do drivers like the sort of one pedal drive with the regeneration?
Yeah. As with any cross section of society, there are people that prefer the older internal combustion engine, but I think the electric buses have been welcomed to the depot, and there are a lot of drivers that like driving these buses. As we said before, they're quieter, they're smoother, they're more pleasant to drive. So yeah, the drivers do like driving them.
Well, it's really wonderful to spend some time here at the Leichhardt depot. Thanks very much to Mark Peters for showing me around and showing me the buses and the whole system here. And everyone, make sure you can get on one of these zero emissions buses when you get an opportunity, because they're just fantastic.